All right, here's some help on number 34 on the page 158 assignment. This information is all provided, or all comes from the book. We have this diagram. One thing I need to mention, if I haven't mentioned before, remember the way we indicate that two lines are parallel is by putting these arrowheads on them. Notice that segment RS and this ray have one arrowhead to show that they're parallel to each other, and then the two segments on the side each have two arrowheads on them to show that those two are parallel to each other. All right, so if we're given the measure of angle RST and we're given the measure of angle STU, okay, I want you to take a look at this diagram. Look at segment RS and this ray down here. Do you see how segment ST touches both of those? Well, if segment ST touches this segment and this ray, that makes ST a transversal. So we have a pair of parallel lines being intersected by a transversal. Therefore, alternate interior angles, that would be this angle and this angle, are congruent. So I'm going to mark that. Okay, this angle and is congruent to this angle because they are alternate interior angles when parallel lines are being cut by a transversal. All right, if these two angles are congruent, then their measures are equal. So take these two measures, set them equal to each other, solve for x, and then you could put x back in either expression to find the measure of either one of these angles marked with the yellow arc. Then to find the measure of angle RVT, well, that's this angle over here, RVT. All right, so notice that we have a pair of parallel segments here. We have a ray that intersects both of those, so this ray is a transversal. So when parallel lines are cut by a transversal, corresponding angles are congruent. This yellow angle here and this angle are corresponding. So parallel lines cut by a transversal, corresponding angles are congruent. So once you have found the measure of angle STU, you'll be finished because it's the same as the measure of angle RVT. All right, moving on to number 37. This is the diagram in your book. We're being asked to find the measure of angle 1 right here. Okay, so a little trick that you may not have thought of. What we're going to do is we're going to add a line to this diagram. I'm going to draw a line right through angle 1 that just happens to be parallel to these two lines. Notice these two lines are already marked parallel. So we're going to add a line, or attempt to add a line. I hope I can make it straight. Okay, so I am adding a line of sorts. Okay, and I have drawn this line such that it is parallel to the two lines that were already given. So I'm going to mark them parallel, or mark it parallel rather. Okay, so now when I do that, okay, what I have done is I've actually chopped this angle 1 into two pieces. So what we're going to do now is use our knowledge of parallel lines being cut by transversals to find the measure of this angle and then the measure of this angle, and then we'll add those two measures together to get the entire measure of angle 1. That would be using the angle addition postulate. Okay, so what I'm going to do to make things a little bit simpler, I'm going to erase this 1, kind of get it out of our way. There we go. And now let's take a look at our diagram and think about what we know about this pair of parallel lines and this transversal. Actually, rather, let's look at this line and the bottom line. Okay, we have parallel lines. This ray is a transversal, isn't it? Because it's intersecting both of these lines. When we have parallel lines cut by a transversal, what do we know about alternate interior angles? They are congruent. So if the measure of this angle is 40 degrees, then the measure of this angle will be 40 degrees. All right. Now, take a look at, now we need to find the measure of this little angle to add to that 40-degree angle to get our final answer. Okay, so we are given a 145-degree angle right here. Notice that this angle would be an angle that would form a vertical pair with this angle. Remember, when two lines intersect, we always have two pairs of vertical angles that are always congruent. So if this angle measures 145, then this angle measures 145 degrees. Okay. And now let's take a look at this pair of parallel lines. We have parallel lines cut by a transversal, okay? And when parallel lines are cut by a transversal, remember that same side interior angles are supplementary, all right? So these two angles would be supplementary. If this is a 145-degree angle, this angle will be 35 degrees. Okay, because when parallel lines are cut by a transversal, same side interior angles are supplementary. Okay, so now I think you can take it from here. Use the angle addition postulate to find the measure of angle 1, which is this whole angle. Here, let me mark it. Okay, this entire angle is the measure of angle 1. And you're going to find, ooh, dotted line, surprise. Okay, you're going to find it by adding these two angle measures together. Now, when you go to do number 38, remember 37, number 38 will be a lot like this one. Okay, now I'm going to get you started on number 39. So in the diagram in your book, you have a couple of lines marked parallel to each other, and then we have two different transversals. Okay. Now, the problem asks us to find both x and y. Notice that if there are two unknowns, the only way that we can solve for two unknowns is to write a system of two linear equations. So let me get you started on that. So let's first of all take a look at these two parallel lines and this transversal, okay? Notice that the 10x plus 5y degree angle and the 80 degree angle are on the same side of the transversal and on the interior of the two parallel lines, so they are same side interior angles. When parallel lines are cut by a transversal, same side interior angles are supplementary. So in other words, 10x plus 5y plus the 80 degree angle totals 180 degrees. Remember, the definition of supplementary angles are two angles whose measures add up to 180 degrees. Now, take a look at this transversal that's intersecting the same two parallel lines. And the 72 degree angle and the 15x plus 4y degree angle are also same side interior angles, so they would also be supplementary. So that means that 15x plus 4y, 15x plus 4y plus 72 degrees totals, whoops, let me fix that real quick, sorry. Okay, plus 72 degrees totals 180 degrees. All right, so I think you can see what you need to do from here. Rewrite both of these equations, just simplify a little bit. Subtract 80 from both sides of the first equation, and then subtract 72 from both sides of the second equation, and you'll have a system of linear equations that you can solve using any method, substitution or elimination.